Yeah. We'll see. All right, history of the atom. So, we're going to do two things today. We're going to talk about the history of the atom, and then we're going to talk about the parts of the atom. Now, the thing is, we can't actually see atoms because they're so small, and really it wouldn't make sense. Even if they weren't so small, you wouldn't be able to see them. So, we have this, like our models of what we think they look like. And the models changed over time. And the reason I go through the different models is so you can kind of get an idea of where we're at and what's likely to change in the future, what might change in the future. So, where's my next page? I'm going to do a couple different people, and under each one I'm going to do a drawing, so you can make it however you want in your notes.
Do we have to do a drawing?
Yes. In 1803, John Dalton, our favorite guy, atoms look like John Dalton thought atoms looked like tiny balls. So just imagine a circle or a sphere, no internal structure, it's just a solid sphere. That's it. Oops, that's not really where it should be. There we go. What's so funny? Okay. You both wanted to laugh, didn't you? No. All right. 1897. J.J. Thomson discovered is a C in it. Discovered, that's better. That some parts of the atom are negative. This is important because if it was just a sphere and there was nothing, like if everything inside was solid, it's like a solid ball or something that was just the same throughout, then there wouldn't be negative parts and positive parts, right? So because there's different parts, it means it must have some sort of structure inside. And so they came up with this model, and oftentimes it's called the plum pudding model, but since some of you don't eat plum pudding, it doesn't really help for me to call it that. So we'll call it the chocolate chip cookie. Pudding? Yes. Do you eat plum pudding?
No.
Okay. I didn't think so. Let's call it the chocolate chip cookie model. I guess we could call it the opium model if there was something in the opium. Like anyway, I'm going to show you what I mean. So imagine a chocolate chip cookie, right? It's round. There's cookie and there's little chocolate chips, right? Well, think of it like that. The chocolate chips would be like the electrons spread throughout here. Put little minus signs in here. So there's your electrons, and then the rest of the cookie part, is all the positive matter. So they put some plus signs in there. So the chocolate chips are negative, the rest of the cookie's positive. Think of it like that. Which pie? No, peach pie doesn't have cookies. Anyway, so the particles he discovered we call electrons, and so they decided that the electrons were spread throughout the atom, and then the rest of the atom was all positive material. So this is the model we had here. Next, a guy named Ernest Rutherford, 1911? Yeah. 1911, Ernest Rutherford. I gotta start writing somewhere else. Rutherford. Found that the positive stuff there's positive stuff in an atom. We found that the positive stuff was tightly packed in the middle. I say the positive stuff, I'm talking about the protons, right? So they're tightly packed in the center. So here, back in the 1897 model, we have the cookie model. We have the positive stuff spread throughout the whole atom. Then we find out that if this is the atom, right, the positive stuff is right in the center, just a tiny little place in the center where all the positive matter is. And to give you an idea of the scale, because I can't draw it to scale here, if this nucleus was the size I drew it here, then the outside of the atom would be the size of a football field. So in other words, the nucleus is 10,000 times smaller than the rest of the atom. So all the positive material is packed in this little tiny space, and then the electrons, of course, are spaced out, right? Wherever, just floating around. Okay. So all this stuff I wrote here, if you were a scientist, you would just say atoms have a nucleus, right? So that's what you really discovered. Nucleus just means the middle. And then there's Niels Bohr, 2 years later. Niels Bohr discovered that electrons can only be certain distances from the center of the atom. Two years later. I think I said so. We got it on video. I'll check it later. Electrons can only be certain distances there we go. Can only be certain distances from the center or the nucleus. All right, so let me try to explain this. So here's your nucleus. I'll draw it a little bit bigger. And then there's certain distances, and we'll just draw lines or circles representing certain distances from the center. And the electrons can only be exactly those distances. Really, we say certain energies, but no matter what distance equates to energy, when you have something that's attracting to something else. Okay, so the electrons can only be certain distances. So think about this in everyday life. If you were walking up a ramp, right? You could be 1 inch off the ground, you could be 2 inches off the ground, you could be 6 inches off the ground, you could be 10 inches off the ground. On a ramp, any height is possible. But if you're walking up steps, you can only be certain distances, right? Like, let's say a step is 6 inches high. So you can be 6 inches off the ground, you can be 12 inches off the ground, you can be 18 inches off the ground. But you can't be 5 inches off the ground because a step is 6 inches high. You're either on the step or you're not. Well, it's the same thing with electrons. There's only certain distances they can be from the center of the atom. There's basically these 7 distances or energy levels that we see electrons at usually, and those are the only places they can be. That's what this model says. All right, and we got one more model. That model there, the Bohr model, is what we're going to use for drawings for the rest of the year. The last one, 1926, right? 1926, the Schrodinger, whichever you prefer, equation tells us we can't know where the electron is. We can only know the probability it is in a certain space. Certain volume of space. And we call this the Plow Model. you open your books and look, when you get done writing this, open your books to page 131 and 132, you will see pictures of what the different clouds look like. Actually, 129 has the first cloud at the top, and then 131 and 132 have the other different shaped clouds. So the first cloud is the innermost one with the first two electrons, and they just make like a circle around the atom. And then you turn to page 131, and you see the second cloud, and there's several different ones. And those shapes, those are the spaces where the electron is likely to be. At the top of 131 and 132. So the first one is 129, you see that one circle cloud, and then 131, I'm sorry, not 129, it's 130. Okay, so yeah, it's actually on both pages. So 130, you see that first circle, that's the innermost cloud, and then the next two pages, 131 and 132, those are the shapes of the clouds where you're likely to find the electron. And basically what the physicists did is they came up with where are you have a 90% chance of finding the electron, and that's what those clouds are. Although, you know, if you included enough space to have a 100% chance of the electron being in that space, it would be the whole universe. In other words, the electron could be, in theory, anywhere in the universe, but there's a 90% chance that it's within that cloud. So that's what this model tells us. For our purposes, when we draw atoms, we're going to use this model because it's easier to deal with. That one's messy. All right, so those are the different models of the atom. Now we got one more thing, and that's just going to be the parts of the atom. Does everybody have this one?
Yeah.
Good. All right, 3 parts to the atom. Do a line. Parts of, no, I wanted a circle. Parts of the atom. There's 3 parts, right? Protons, neutrons, and electrons. Those are the only 3 subatomic particles that are in atoms. They're the only 3 subatomic particles that you'll ever have to know about in this class or in high school, and probably for the rest of your life unless you major in physics. We're going to make like a table here. So we'll do 1, 2, 3, 4. This will be blank. And so here we're going to do protons, neutrons, and electrons. Three parts of the atom. We're going to do position. That's where they are. We're going to do number. Leave some space because we're going to write stuff in here, so make it enough space. That's why I erased that list. Charge. I'm going to run out of space. And changing number of. So if we change the number of one of these things, what happens? Number of protons, number of neutrons, number of electrons. All right, so first thing we're going to talk about is where are these things located? Where are the protons? Anybody know? In the middle. We're going to call it the nucleus, but that's all it is the center of the atom. Basically, anytime you hear nucleus, just means the center. Same thing with the cell. What about the neutrons? Nope, they're also in the nucleus. So the protons and neutrons are packed into a tiny little space in the center of the atom. And then the electrons, those are on the outside. So yeah, in the ring, we'll just say outside. So really the outside of the atom is the electrons. That's all there is. All right, number of protons. So this is just the atomic number. So every day when I have you write that list on a periodic table, and number 1 is hydrogen, and number 2 is helium, and number 3 is lithium, that's how many protons an atom of that element has. If I say how many protons in an atom of lithium, it's 3. How many in an atom of aluminum, it's 13, and so on and so forth. Neutrons, you have to do atomic mass, which doesn't start with a T, atomic mass minus atomic number. So they thought that they would make your life easier by writing the mass on the periodic table instead of the number of neutrons. Instead, it makes your life harder. So if you look at lithium on the periodic table, for example, you see Li, and on top there's a 3. That's the number of protons, the atomic number. And then on the bottom it says 6.941. We'll just round that to 7. Okay? And so what we're going to do is just 7 minus 3 equals 4. That's the number of neutrons in an atom of lithium. Electrons, for now we're going to say same as atomic number. So same as the number of protons. That's not always true. That's true most of the time. Sorry. We'll get into that later. Charge of a proton? Positive. You can put a plus sign or you can write positive. I'm going to put a plus. Charge of a neutron? 0. It's neutral. Okay, you guys want to hear a really, really bad chemistry joke?
Well,
You're going to hate it because it's terrible, but okay. Yeah, that's true. Now everybody's going to hate this joke. It's really not funny, but I'll tell you anyway. So, neutron walks into a bar. And you can tell it's like going downhill already. So neutron walks into a bar and he orders a Coke. It's on TV here. And anyway, he gets his bartender, gives him his drink, and the neutron goes to pay. Bartender says, no charge. Yeah, I told you it was bad. And it just gets worse after that because that's the best chemistry joke there is. So it's all downhill afterwards. All right, negative. I'm not going to put a minus sign because it would look like a dash and you would forget what it means. So write the word negative for electrons. So protons are positive, electrons are negative, and neutrons are neutral. Okay, last thing. If we change the number of protons, what happens? What changes? Well, it changes which element it is, because how many protons determines what element it is. Right, so it changes the element. So if I have 3 protons in the nucleus, that's an atom of lithium. If I change it to 4 protons, that would be beryllium. If it was 5 protons, it would be boron, and so on and so forth. That's what makes it what element it is. Neutrons, different number of neutrons would be a different isotope. I mentioned this yesterday. So if I have lithium with 4 neutrons and 3 protons, and I added or took away neutrons, it would still be lithium, be a different isotope of that same element. And if you change the number of electrons, if you add or take some away, it becomes an ion, it has a charge. And these things we'll talk about more later. Well, not this one, but these two we'll get into more. Questions on any of this? All right, we're done. Woo!
Yeah.
It's not easy.